Hello everyone. So let's start today's session with a fourth program. The title of the program is Implement Ethernet LAN using N node. Implement Ethernet LAN using N nodes and assign the multiple traffic to the node and obtain the congestion window for different sources and destination set. Okay. So as you can read the title, here we have to create a Ethernet LAN which is similar to our previous program, and we have to assign a multiple traffic to the network, and we have to verify what is the amount of data transmitted, or we have to get the inferences between the data transmission from source to the destination via one important parameter that is known as congestion window. Here one important thing is what is congestion window, why it is used, that you have to study. And here this congestion window or the particular program what we are learning here is applicable only for a TCP protocol. Okay. I repeat, this is applicable only for TCP protocol because we know that TCP protocol is connection oriented protocol. Okay, and UDP is a connectionless, but this is applicable for connection oriented protocol where the sender will very sure that all the packets will be transmitted successfully. Okay, so what is this congestion? So congestion refers to the network state where the message traffic becomes so heavy that it slows down our network responses. Okay, hence the congestion becomes some very important issues that can arise in each case wherever a packet switch network is used, and because of this congestion it leads to the loss of packet in the transmission medium. So here we can see it is very important to control the congestion in network, but it is not I can say that it is not possible completely to avoid, but up to some extent I can control the congestion. Okay, so congestion control basically refers to a method or a technique that is mainly applicable either to prevent the congestion before it happens or remove the congestion after it happens. In whichever method you can go and you can implement the task. So the TCP reacts to the congestion by reducing the sender window size. Okay, the size of the sender window size is determined by very importantly two different factors. One is what is the receiver window size, and second factor is congestion window size. So we will see what is this receiver window size. The receiver window size is just like it tells how much data, it may be in byte, how much data the receiver can receive without acknowledgement. That means the sender should not send a greater than the receiver window size. Otherwise what happens is it leads to dropping the TCP segment, which causes the TCP retransmission. Okay, so that means in receiver window size I should ensure that whatever the packets I am transmitting, that should be less than the receiver window size. Next, coming to congestion window size, here sender should not send the data greater than the congestion window size. Otherwise it leads to a drop in the TCP segment, which causes the TCP retransmission. So the sender should always send the data less than or equal to the congestion window size. In practical, we have different variants of the TCP users with different approaches in order to calculate the size of the congestion window. Okay, the congestion window is known only to the sender and is not sent over the link. Okay, so we can see here one figure. I will show you how to set the congestion window. Let's assume you have a maximum MSS. MSS here it indicates maximum segment size. Maximum segment size. So I have a one line sender, another receiver. So let me assume initially my congestion window size is one maximum segment size. That means I am sending one packet. At the particular instant of this duration, I will be getting acknowledgement back. Okay, that is one segment size. Let's assume, hence you have got an acknowledgement within that particular instant. So why can't you send two packets at the same duration? So I will be increasing the congestion window size by 2. That means at this duration, I will be sending two packets from the sender, and from the receiver I have to get two acknowledgement back. Similarly, if you want to increase the congestion, means without any drop packet for the previous method, for the previous two cases, like when it is equal to 1 MSS or it is equal to 2 MSS, if without any drop, if you are getting the acknowledgement back and packet is transmitted successfully, then you can increase your congestion window size by a method that will be known as a round trip method, and it will be evaluated through this particular formula here. So each one round trip of congestion window is an exponential to the power of 2. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that it keep on increases. Somewhere let's assume your packet is dropped, then it will stop accessing the data and the same process will continue. Okay, so in this case we have to get the threshold for the maximum packet to be transmitted. So the maximum number of TCP segment that receives the window size can accommodate is always divided by 2. That means receive window size divided by maximum segment divided by 2. Okay. So with this basic concept, so we'll start how the program is written in order to obtain the particular congestion window. Okay. So for this program, if you create a statistical not statistical result, if you see how the packet is transmitted and in what way the multiple traffic means two different set of sources I can assign with respect to two different set of receiver. More than 2 also you can accommodate, but here I have taken 2 set of TCP source and 2 set of sync receivers. Okay, so the given bandwidth of the duplex link, how it is effectively utilized by both the transmission. Let's assume I have a 10 MB of bandwidth and 2 set of transmission is there. From sender 1 to receiver 1, let's assume it is going to take 9 MB of bandwidth. Total bandwidth is 10 MB. Now out of 10, 9 MB is utilized by first pay. So what is the bandwidth is left out? Only 1 MB. Then the second transmission, the second traffic set has to compromise with that particular value. Okay, that means multiple traffic here, it actually compromises between the transmitter and receiver, which tells that a particular better 100% transmission may be taken place. Okay, so one more thing you need to remember here, this particular multiple traffic case, actually it is not suitable for longer distance communication. Okay, this type of congestion window application generally we cannot apply for longer distance communication. Okay, so we will see the program now. So see here, first is C, create the instances, create an AMP file and trace file. Okay, then I have to create a node. How many nodes? Generally they said Ethernet of n nodes. So according to your requirement you can select. So here I have taken 8 nodes, n0 to n7. Okay, so you know how to declare the node by this type. So next is what? These nodes are connected via a LAN network. Only one LAN is enough because all the nodes I will be connecting to with this particular LAN. Okay. So in the previous program we have seen how to create this LAN. So same syntax is allowed. So my object name, my NS, make LAN, and LAN is connected between the node N0 to N7. The bandwidth is 3 MB. Propagation delay is 30 millisecond. Logical length of drop tail queue, and it belongs to a IEEE standard MAC 802.3. Out of this N0 to N7, I will select N0 as my source 1 and N7 becomes destination 1. N4 becomes source 2 and N3 becomes destination 2. Just I have given the label which nodes are source and which nodes are destination. According to like statement multiple traffic, so two pair of source and receiver has been selected. So now you know how to initiate my transport agent and then application layer protocols with respect to these pair of transmitter and receiver. Okay, so accordingly this statement has been implemented. Okay, N0 TCP agent, then attach that to FTP of transport layer, and N7 becomes sync. Similarly another site. So TCP N4, then at the receiver N3 is my sync, then connect it. Okay. So after that, as two transmitter is selected, I will select two different types of classes for transmission, class 1 and class 2. And as I said beginning, here I have to see how the traffic is used by the pair of source and receiver within that given bandwidth. So for that I have to create a congestion window, and at each instant of time how it is accessed, and for in order to see the result I have to create a graph for that. Okay. So here I will be implementing a TCP window values, and I have to every time once the program is executed the data should be written. So for that a two set of congestion 1 and congestion 2 output file is open. So congestion 1 and congestion 2 output file. So initially it is empty. Once the program starts, according to the timing slot, the data is written into these two files. So one for first FTP1 output file 1, for FTP2 output file 2. Okay. So now we have written a simple procedure in order to plot the graph. Okay. So this graph is plotted with respect to two parameters. One is plot window with respect to a TCP source, and I am accessing with the out file. Okay. So every time when you invoke, you will evaluate what is the current time, and also you will see what is the congestion window. Okay. At that particular instant of time, which transmission has taken maximum bandwidth and which pair of transmitter and receiver has taken less bandwidth. So like that variations can be seen. Okay. So all the data is recorded in the file through this congestion 1 and congestion 2, and accordingly the graph is plotted. Okay. So in order to plot the graph, as I said, two parameters I need, current window and current time. So every time the current time is incremented whenever it executes, and also the congestion window size is also incremented, and that value will be put here and graph is evaluated. So we have two different graph here. So one I will represent with red color and another graph I will be representing with green color, just in order to make a differentiation. So as I said, we are plotting the graph, then I have to ensure that what is the geometrical size of the graph. So the geometrical size of the graph is represented by a particular statement like what I have written here. Okay, so execute X graph with a congestion 1 or congestion 2. A geometrical area is 400 cross 400. You can do the changes here and you can see the graph size also. Okay, so next I will be calling when to plot both the congestion window. So what is the start time, what is the stop time, when it has to finish. Then finally run the program. Okay, so this is a simple task where additional thing what we have added here is creating a congestion window, multiple traffic, and how to execute the graph. Okay, how to plot the graph. Except the rest of the code is similar to your third program. So now we will execute this and we will see what the result we will get. So let me clear everything first. Clear all. So what is the program name? Program name is N4. Let me check once. N4.tcl. Okay. So the execution command is ns space file name N4.tcl and then ampersand. Okay. So what we are getting? We are getting a graph here. Okay. See the graph. I have maximized this. Or else let me minimize the things. Not an issue. So when you see this graph here, I have x-axis and also I have y-axis. And along this graph, congestion 1 and congestion 2 dot xg graph has been generated. So when you invoke, when you verify the result here, what we have got, none of the two transmissions has reached at a maximum value. That means both cannot take, as I said beginning, 10 MB of data means both has to compromise within the 10 MB and they have to do the transmission of packet or transmission operation. They cannot take 10 MB, 10 MB each at a time. One is taking 10 MB means other has to take rest, like it has to stop its transmission. And if the one is taking some just 5 MB, other can also take 5 MB of data. Okay. So similarly, when you compare those theoretical concept with this practical graph, what we have got. So one is at maximum. See from here at this instant of duration, green color congestion 2, second set of TCP and sync 2. They reach here, but their first one is less. If first one goes at a higher bandwidth, then second one is at a lesser. So there is a compromise between both. Okay. So this is one of the method where we can have a control over our congestion window and will ensure that all the transmission of the multiple traffic should pass through this particular window and there should not be any drop packet. Okay. I hope the concept is clear for everyone. Keep learning. Thank you.